Um, you guys got some questions to start? Piercy.
Could you do 13 from 6 to 5?
6, 5.
Yeah, 6, 5.
13. Oh, yes.
What?
Okay. So, since f is continuous,
Wait, hold on. Is that 6, 5?
yes.
7, 1.
Oh,
I'm very sorry.
that's okay. Makes a big difference. I'm like, oh, this is like just quoting the mean value theorem, and like it all just falls right out for you. That makes more sense. All right, let's see here. All right, integration by parts should be pretty clear here, right? The product of two things. And if you tried to do a U sub, they ain't gonna work. All right, so what do you want to pick for U and what do we want to pick for dV? U should be T, dV should be secant squared 2T, dt. So du is just dt. And dV then is going to be a U sub problem here, right? So this should be tangent of 2t, well, 1 over 2, tangent 2t. That okay?
How did you get tan out of that?
Okay, so we're doing the integral of secant squared u times du over 2, right?
Yeah.
So the 1/2 comes out front. And the antiderivative of secant squared is tangent.
Okay.
And then we just put our u back in, right?
I got you.
So just move you guys out of the way. All right, so we have then the integral of t secant squared 2t dt is equal to u times v minus the integral of v dt. Now, do we have a antiderivative formula for tangent? No. So what are we going to do there? Okay. So here's the trick. I'm going to use trig to rewrite tangent 2t as sine 2t over cosine 2t. Cool with that, Pierce?
Fine.
Or rewrite tan 2t as sine 2t over cosine 2t. And now I'm going to do a u sub there. I'm going to let u be cosine 2t. So du dt is negative sine, well, negative 2 sine t, or sorry, negative 2 sine 2t. So du over negative 2. Actually, let's just, du over negative 2 is going to be sine 2t. So if I take this, that, yes, sorry, dt, thank you. Very good. So if I take that, I'm going to have that negative 1/2 and the integral, and then I'm going to have 1 over u times du over negative 2. Ben, I have this stuff for you here. I didn't know if you were here or not.
Yeah, some weird stuff going on.
Yeah, no problem. So that's going to just give me 1/4 natural log of cosine 2t. Does that feel okay, Pierce? And that ought to do us, right? Just a plus c at the end. So I suspect that's the answer in the back. I guess I should look, right? But that felt pretty good doing it. What's up? Yeah, that's one of those things like you don't think of it right away, but once you've done enough of these, you're like, what do I do with this? Trig, time for trig. Let's see here. Yeah. The back of the book answer differs in this, but we're equivalent. So they have minus 1/4 natural log of secant 2t, but if you push the negative inside the logarithm, because that negative 1 exponent, and it flips to cosine, there's an equivalent answer. So I'm not going to monkey with it. I like it better with plus and cosine rather than minus and secant. Yuck. They might have used an identity there to do the integral of tangent. I think we did that at one point as a u sub problem. They might have used that identity that we'd come up with and shortcutted to there. Yeah, I don't remember the identity, so I just did it as a u sub again. But that would have been the trick there, Pierce. Yeah, no problem. Other homework questions from anybody's? Yeah, Pierce. 9.1 number 3.
Oh, yeah.
Ooh, this would make a good test question, I think. Okay, so I want to start by calculating y prime. What's the derivative of e to the rx? re to the rx. Excellent. And what's the second derivative then? Beautiful. Love it. So now I'm going to plug in things to here. So I have 2r squared e to the rx plus r e to the rx plus e to the rx. Oops, sorry, minus equal to 0. So far, so good. I'm going to go ahead and notice that each term of that has an e to the rx in it. So I'm going to factor that out. Oops. And I'm going to apply the zero product property. I know that an exponential is never going to equal 0, so that has no solution there. And then I'm going to look for either a way to factor 2r squared plus r minus 1 equals 0 or use the quadratic formula. Either would be appropriate. This should be an easy factoring one, so I'm just going to try to do it by factoring. So let's see, that needs to be the plus and that one needs to be the minus. So r should be 1/2 or -1. Does that feel good there?
I did like almost all that, right? I just got confused. I don't know if that got the all.
Yeah, so it sounds like you're right on the right track. For part B, then it just wants you to go back and plug in the values for R that we just found, like this would be R1 and this would be R2, into this guy and just repeat the same thing.
Okay.
Just repeat what we did. It gets a little messier because it's a little bit more complicated, but everything should just cancel out and you should just end up at 0 again, would be the idea. I'm going to skip doing that because, yeah. But I think that's appropriate for where you guys are at to be able to do something like that. That's a reasonable test question. Yes, sir.
For the test question, would you also include the part B for that?
No. I think just part A would be enough, right?
Yeah, that's.
Yeah, not bad, right? Ava, is that a hand or a stretch? Yeah.
It was kind of a.
Yeah, sure. 2 for 1. Anything else? All righty. Let's go and get this chapter 5 or chapter 9 all finished up. We're going to do 9.3 and 9.5 today. So, yes, please.
I just have a, for 9.2,
Mm-hmm.
the whole like second part of the homework.
Oh yeah, you shouldn't have asked you to do that because
Yeah.
we didn't do Euler's.
Yeah.
So like whatever 19 to whatever you should skip.
Oh, okay. Opposite.
Yeah, 19 to 23 just skip that. Yeah. Yep. Because it's asking you to do Euler's method, and I skipped doing that. Euler's method, just as an aside, is like a way to find an approximate solution to a differential equation. Like, pretty useful, but it's a BC topic, and like just trying to fit everything in for the end of the year or whatever. So I elected to omit doing that. After this test, maybe we come back and we can talk about Euler's method and do like 20 minutes or something on it and a couple of examples and go on about our business. Because it's nice to see. If you take a Calc 2 class, you'll probably do it. Or especially if you do a diff EQ class, differential equations, you'd certainly do it there. But sometimes you can't do all the BC stuff, All right. So a separable differential equation. So we say a separable differential equation is a first order differential equation in which the expression for dy dx can be factored as a function of x times a function of y. So for example, if I have dy dx equals f of x times g of y, that would allow me to divide both sides by g of y and multiply both sides by dx, where I have the x's on one side and the y's on the other. Everybody see that? That's what I was able to do. And then if I integrate both sides, those should be two integrals that I can do. I can integrate with respect to y on one side, integrate with respect to x on the other side, because there's no mismatched variables. Everything is very easy, piece of cake. That's the general idea here. Let's do some examples. Cool? All right. So let's say we have the differential equation dy dx equals x squared over y squared. So my first order of business is try to get the x's on one side and the y's on other. So I'll multiply both sides by y squared, and then multiply both sides by dx. Now, since everything is separated, I can integrate with respect to both sides. What's the antiderivative of y squared? Good. And x squared is then obviously, yep. And then I'm going to have a plus c at the end, right?
Wait, you have it with the y too?
You could have put it on either side. It doesn't matter. You only need one of them, though, because it's like C1 on one side, C2 on the other. You move them onto the same side, and we'll just call the new one C1 minus C2 is C, right? Like, it's fine. To some extent, you can be kind of hand-wavy with the constants, and everything is fine. So I'm going to do part B here and then come back and finally just get y by itself because it's going to be easier to solve for C now.
You're just plugging the 0, right?
I'm going to plug 0 in for x and 2 in for y. So if I do that, what do I get?
Eight over 3 minus.
Yes, Chanel?
Wait, why would you plug 0 in for x and 2 for y?
Well, it says y of 0 equals 2.
Oh, okay.
Like y is a function of x. So C is 8/3. Everybody cool?
So when I know, I'll send it. Oh, thanks. Sorry. Yeah, that's right.
I'm going to now multiply both sides by 3 in an effort to get the y by itself. And then just do the cube root of both sides. Oops. What do you guys think? Braids? No, because radicals don't distribute. It's like an exponent, right? So that's stuck the way it is. That's as good as you can do. Good question, though. That's a thing that we often get confused on is distributing exponents, right? That's an easy algebra mistake to make. You feel okay doing that, though? No big deal, right? In fact, the calculus there was pretty easy. Let's do another. So again, I want to get the y's on one side, the x's on the other. So let's multiply both sides by 2y plus cosine y. And then the other side by d, or both sides then by dx. Integrate both sides. The antiderivative of y squared is, I'm sorry, I just gave it away. 2y is y squared. What's the antiderivative of cosine?
Sine y.
Sine y. Because the derivative of sine is just cosine, right? Okay. And then the antiderivative of 6x squared. I think you mean 2x cubed.
Yeah.
And then we'll put a plus c there. Am I going to be able to get y by itself here, though?
No.
No, why not? Because I have that sine of y in there also, right? There's going to be no way for me to get the sine separated, so this is as good as we can do. Just we're done. Sometimes you can get y by itself. Sometimes you won't be able to. Frequently when you have addition or subtraction going on, it might be difficult to get y by itself. Or impossible, in this case. Let's do another. Y prime, what am I going to do with that? Yeah, I'm just going to call it dy dx. So divide both sides by y and times by dx. Excellent. Integrate both sides. Antiderivative of 1 over y is?
Natural log of y.
Close. Yeah, I need that absolute value in there. And the antiderivative of x squared is? Okay, and then I'll put my plus c there. Now let's get this y by itself. What do I have to do that? Get the y by itself. Yeah, so I'm going to do put both sides to the, I'm going to do e to both sides. That's probably the way to say it. And how do I get rid of that?
Plus or minus the u.
Yeah, very good. But almost assuredly, this is not what an answer on a multiple choice test would look like. They would do this. Right? Because addition in the exponent is the same thing as multiplication of bases. And e to the c is just a constant. So we'd probably write it that way. That okay? Again, the calculus techniques involved, pretty easy, right? Like nothing hairy here. That's kind of the gist of it for separable. No big deal, right? Okay. What if they're not separable? So one type of inseparable differential equation is called a linear differential equation. So linear differential equations are of the form dy dx plus some function of x, that's p of x, times y, equals some other function of x, we'll call q of x. So p of x could just be a number like 1. It could be x squared, could be the natural log of x, it could be x plus 7, could be all kind, like any function of x. And the same with q of x, right? Could just be a number, like 1, 2, 3, 7, whatever. Or it could just be some function of x, like x squared minus 7. Like whatever. Is everybody okay? So let's look at an example of a linear differential equation. Let's first examine why it's not separable. So if I took this and try to separate it, what might we do?
Solve for x or y.
Well, we want to get the y's and x's on like all the y. We want function of y times dy and then a function of x times dx. So if I divide everything by x, and it's okay to do that because I have this, I'd have dy dx plus y over x equals 2. So maybe you move maybe we do this. But if we try to get the y by itself, we'd have to you make maybe a common denominator over here and you're like, oh, but I can't move. If I move the numerator over, I am taking an x with me. There's really no way to get those separable, right? Can't do this. It just will not work. So what can we do? Well, in this case, I noticed that the left-hand side, x, y prime plus y, is the product rule derivative of xy. Now, what I'm doing is walking you through an observation. This is not how we'd actually do this. So, I wouldn't write anything, just kind of watch. And we'll build out the method here by the end, and it's much nicer than what we did, but I want to show you why we're doing what we're going to do. So if I do that, I can rewrite the left-hand side as the derivative of xy. Now, when I integrate both sides, I have just an x on the right-hand side, and this integral is just going to cancel with the derivative, right? So I'm left with xy, and then the antiderivative of x is easy, or 2x is easy. And then I can just divide both sides by x. And there I did it. So the thing that this relies on is being able to do this step, right? So let's work this out kind of generally here, and then we'll run through some specifics. All right, so in general, I have some linear differential equation. What I'm going to do is I'm going to multiply both sides of that equation by some function I of x. This I of x is referred to as an integrating factor. And we're going to choose this I of x in such a way that when I multiply the left-hand side by I of x, it is then the product rule derivative of I of x times y. So to allow me to do that same condensing that I was able to do in the previous example. So you know how in like completing the square where we add like b over 2a squared to both sides and it automatically lets us factor the way we want it to? This is the same idea. I'm going to choose to multiply both sides by this I of x so that I can condense the derivative or condense it into a product rule derivative without having to think about it. Okay, it's going to be guaranteed to do it. Now, I haven't yet described how we're going to figure out what this I of x needs to be, but just run with me that we can do it for a moment. Okay, so if we're able to find that I of x, we can condense the left-hand side into a product rule derivative. When we integrate both sides, the integral cancels with the derivative, and then I can divide both sides by the I of x to solve for y. So this is going to work every time. We just have to figure out how to pick that I of x. So what we need for I of x to do is it needs to satisfy this. When I multiply to the left-hand side, it's got to give me the same thing as the product rule derivative of I of x times y. So all I'm going to do is do that algebraically. So I multiply both sides by I of x, and I get this. I do the product rule derivative with respect to x, and I get that. I notice that, hey, look at this. Those guys are the same. I just subtract that from both sides. They cancel out. I look again. Hey, look, factor of y. Divide both sides by y. They cancel out. So this p of x is going to equal 1 over I of x times di. Thanks.
You're welcome.
And then if I don't know. It's like some necklace thing, and there's some stuff written on it. I don't want to take a pause to read it because it's like a lot of words. I'll read it eventually, but like I'm in the middle of something, you know. So we're here. If I integrate both sides, this antiderivative is the natural log of I, right? So when I do e to both sides, I get that some constant times e to the integral px dx is going to be my I. That's the takeaway. That's my cheat code for doing these separable differential equations, is that I'm going to just figure out my I, which is always going to be e to the integral of px dx. Then I can multiply both sides by I, condense it into a product rule derivative, integrate, divide both sides by I of x, and be done. Let's do some specific examples. So the first thing I want to do is I want to make sure that I am in this linear differential equation form. And that looks good, right? I have dy dx. I have some p of x. I have my y. And then I have my q of x. Everybody feel good? We're in the correct form?
Yeah.
So I'm then going to compute my I of x, which is always e to the integral of p of x dx. What is the antiderivative of 3x squared? X cubed. So I'm going to take this equation, my linear differential equation, and multiply both sides of it by e to the x cubed. Everybody feel okay there? What's up? Oh, sorry. Yep, I just typoed it. Thank you. Good attention. All right, so this piece right here condenses into the derivative of I of x times y. Always. That's why we've chosen I of x the way we have, is so that I can make that condensing every single time. I don't have to think about it. I know that that's how it has to work. Okay? It's automatic for me. At this point, I can then integrate both sides. Yuck. The integral cancels with the derivative. Now, how am I going to integrate 6x squared e to the x cubed? It's a u sub. Everybody okay there? So that integral becomes 2 e to the u du. Is everybody okay with the substitution? 6 times 2 is 3, or 3 times 2 is 6. Okay, what's the antiderivative of 2 e to the u? Also 2 e to the u. So I'll just put my u back in. And then have a plus c. Everybody feels good so far? Okay. I'll divide now both sides by e to the x cubed. So that gives me y equals 2 plus, and I'm going to write it this way, c times e to the negative x cubed. You could write it as c over e to the x cubed would be fine also. And we're done. Emma, what's up? Sure. Okay. Let's do another. Notice this one, we're also given an initial value. What does that mean? Yeah, we're just going to be solving for c at the end. Like, no big deal. Everybody cool? Same idea. So first things first. I notice right away, not in the linear differential equation form, right? Because I have something times dy dx. What's up?
Did I leave a red blue bag in here by chance?
You can look. I didn't notice anything.
I was just in here during the season.
Yeah, she was just being rowdy.
Thank you.
Yep. So I'm going to divide both sides by x squared. Everybody's okay with that? Why is it okay to divide by a variable here? It's not equal to 0, right? So it's free to divide by a variable there. Okay, so what is my p of x then? it is 1 over x, right? So my I of x, that's what I need, is going to be e to the integral 1 over x dx. So e to the natural log of absolute value of x. The e cancels the natural log, and the absolute value of x is just x. Why can I say that? Because x is positive. Thank you very much. I really appreciate that, not having to drag that absolute value through there, because I have no idea what to do with that in an indefinite integral. All right, so I'm going to multiply both sides by my integrating factor. The left-hand side just turns into the derivative of my integrating factor times y. And the right-hand side reduces to 1 over x. Integrate both sides. Integral cancels the derivative. And we have xy equals natural log of x plus c. Notice I dropped the absolute value because we know x is positive. And here I'm going to take I know x is 1 and y is 2. So I'm going to solve for c right here. So I get c is 2. Everybody good there? So I can say then y equals the natural log of x plus 2 all over x. Is this feeling okay? In general, I think this is pretty straightforward. Like, there's some stuff to memorize or whatever, like the formula for the integrating factor, and make sure you have the formula for a linear differential equation, but like the calculus parts are usually pretty straightforward. All right, let's do one more. So this one I noticed right away is already in linear form, right? So my I of x is going to be e to the integral of 2x dx. So e to the x squared. So that's going to give me d dx of e to the x squared times y equals e to the x squared. Integrate both sides. Right-hand side, the integral cancels the derivative. Now, what am I going to do with the right-hand side, though? What's the integral of e to the x squared? It's not e to the 2x. Well, what if I try to do a u sub? Is it going to work? Right? If I tried to use u, it'd probably be x squared, but then du should be 2x dx, and I don't have a 2x. Integration by parts is not going to work either. If you tried to do integration by parts, you'd have like your u would probably be e to the x squared, so the dv would have to just be dx. But the derivative of this is 2x e to the x squared dx. And that's not going to help me because I'm going to have to integrate that at the next step, and I'm in the same boat, or just as bad of a boat as I was before, right? So like none of this stuff works. Guess what? It's fine that it doesn't work. There's no closed form formula for this. So I'm just going to put my plus c on there and divide both sides by e to the x squared. And I'm going to write that as a final answer. And I'm not going to do it because it's a perfectly reasonable formula. No. Yes. Yeah, no problem. Now, will that happen in the homework? Possibly. Would I do that on a test? No way. I'll give you things that you can do integrals of, but like when you deal with differential equations like this, we've talked about how in general differentiation is easy because we have a formula to do any kind of problem. Integration is hard because we don't have antiderivative rules for every kind of problem. In fact, something as simple as e to the x squared, taking the integral of it is not feasible. Like we can't just take an integral and get a formula. Now, in practice, doing our integration problems typically has been easier than the derivative problems because they don't get the same level of complicated, and the algebra is typically not as bad. But in practice, like in all cases, integration is much more difficult than differentiation, at least for like continuous functions. You blow up continuity and then things get weird. And I don't want to say anything about that. Or if you take or if you take like complex functions, like functions that operate on the complex numbers instead of just the real numbers, I don't want to say anything about that. But for the stuff that we're doing right now here, what I've said is true. So yeah, that wraps up 9.3 and 9.5.
Do we have any more lessons?
So the test will be the last test. Now I'll do a couple of like supplement like lessons here as we do some review, just to like do some BC topics that would be good for people that are going to take Calc 2. That these are good things to see, and there's no harm. We've done all the background we need to do some of these things. But in general, when we get back from spring break, we're just going to be reviewing, and then like once every week or so, I'll scatter in like 20 or 30 minutes of something. And then we might do a couple of examples from it, and then we're just going to go back to review.
If we need it after this test, can you do some like grade boosting things when we come back? If we need it.
I don't know.
Pretty please.
We'll see. What is your grade right now, even, Talika? It's pretty good, isn't it?
Yeah, it's fine. I like it could be better.
Just give everybody 100.
Yeah.
So this is the end of it, Mr. Kool-Aid.
Yeah, this is like the end of the stuff.
Guys, well,
It was a long year, guys.
Look,
It was a really long year.
I didn't take it easy on you guys either. Like I busted your humps, and like we did a lot of stuff real fast. You should feel real proud.
I can't believe it. We survived AP calculus.
Yeah.
honestly, I was pretty sure I'd be able to survive it after 18 now.
Still another chapter.
Yeah, it's not over yet.
All right. For the test format or the test days, it sounded like from first hour's perspective, the best option was to do one half on Thursday next week and the other half on the following Tuesday. I think that makes sense. I'm going to do this half on the Tuesday, and
Better.
this half on the Thursday and this half on the Tuesday, because I think it's a 45-minute class on Thursday, and I think this will be shorter, which is 2 FRQ questions on there, than this that has like more questions, really. Does that feel okay? I'll try to soon go through this and kind of give you some book problems that would be similar to these things. But for this Thursday, what I would do is I would do all these FRQs that I left you in the packet. Like,
For Thursday?
yep, if you do those and you feel good about those, you should be feeling good. Okay, I think there's 7 or 8 of them I picked. 8. So they should be pretty similar. Should be relatively doable. I have keys in there for stuff. Cool? Okay. So as a reminder, we talked about this first hour for a minute. So from, oh boy, that's, come on.
Yeah, you need, I think you need like a 70% to get a 5.
So again, this was 2020's breakdown. So this might float a point or two, you know. But look at the boundaries.
That's not bad.
You can get less than a 50% and get a 4.
108.
There's 108 total points.
I just need a 4 to get the credit in college.
I need a.
Well,
We won in Michigan. So
And here's
yeah, they need a 5.
here's what I'll tell you guys. Here's what I'll tell you. With what I've asked you to do and what you've done demonstrated to me in class, not a single person in here is not capable of getting at least a 3. All of you are capable of at least a 3. Okay? What'll separate it is, did you try for the entire test? There's 4 parts to it. And if you get frustrated and quit, that's how people get 1s and 2s. Okay? If you just like, I'm done. But that's dumb. You're there for the 3.5 hours regardless. You ain't going anywhere. You might as well try, because a 4 or a 5 is literally thousands of dollars. It's 4 credit hours if you get credit. It's 4 credit hours. That is like $3,000 or $4,000 of tuition for taking a 3-hour test and trying the entire way through. You know? Like, just keep that in mind when you're doing it. It's like, oh, this is so hard. I'm tired. I just want to quit. Remind yourself that all you're doing is like a little bit of effort for a chance at like $3,000 or $4,000 when you have to stay there anyways. It's not like you can go leave in the middle of the test and just go do something else. You're stuck there. Just try. Joey.
Do you know what day it's on?
Yes.
No, something.
So please tell me what date.
It's not.
May 13th.
That's the first exam.
Wait,
I would hate that.
when is like,
Response was 18.
Because if this is my
It's a
last,
Saturday.
It's
Saturday.
It's Friday,
That's your last?
as long as this isn't the last AP test, I think.
No, AP Bio is our last
What?
AP
Freaking
exam. It's the
Friday.
very last one
We're on
that we
school.
take. It's like
Especially
May
Make
15th. Something like
Yeah.
that.
Proms Friday.
So this is probably the
I
4th.
thought it was.
I wish I made calc like the very first one.
I want to get help for EP Lit's my first
Oh,
one.
yeah, no, prom is a Friday because,
Second one's AP
AP
Psych,
Physics
and then
has
AP
their
Health,
final
Bio.
on, it's coming.
So, just reminder, the test breakdown. So there's 45 multiple choice question, 30 without calculator, 15 with.
Oh, shoot, you're right.
This 30 questions represents 1/3 of the points. This represents 1/6 of the points. And you can see the times. There's an hour for the 30 and then 45 minutes for the 15. And then there's 6 free response questions. The first 2 are calculator alive. That's 1/6 of the total points. And then the last 4 are no calculator. Those are 1/3 of the total points.
How are we gonna get this done this fast?
Is that it?
That's the test.
Oh.
It's 45 multiple choice questions, 6 free response.
Oh. That's it.
And again, nobody's expecting you to finish every question in every section.
Oh,
Right?
there's no way. An hour to finish 30? I can barely finish 5 in an hour. Okay.
Okay?
Yeah.
So again, look at the grade breakdowns. If you finish half and feel like you got all those right, that's great. That's a win. You know, if you guess the rest of the half and get a quarter of them, you should feel like you're in good shape. You know, like, everybody's okay?
Yeah.
But think about the tests that we've taken in class. I wrote you guys difficult tests, very AP centric, a lot of AP style questions, a lot of AP questions, period. How often did you score below 50%? Almost never, right? Most of us got over 50s even without curves regularly. Right? And what's a 50%? It's a 4. It's a 4. Right? Like, you guys can do this. You can do this. This is eminently doable for you. Will we have to prepare? Sure. Will we have to do some studying when you're not in class after school ends? Yeah. But the good news is we'll have like 2.5 or 3 weeks that we can work on this stuff in class with me. That's a lot of studying you'll get done. Ideally, by the time we're done, all that you'd need to do is go back and review the stuff. You're like, I'm kind of shaky on this 1 or 2 things. And that's the stuff you'd work on without me.
I need a 4 on AP calc. You get credit hours.
I think you can do that. I really do. Don't doubt yourself.